And let's get started. So the first problem here, we're just jumping right in. We're going to use long division to divide some polynomials. But before we do that, let's go back and review old school division, because this right here is going to be a big deal in terms of the polynomial long division. So let's review this real quick. So if you have 1,569 divided by 13, does anybody remember how to do this process? Because it's probably been a while for a lot of folks. What's the first thing we should be doing here? All right, so like, if you look at 13, how many times does 13 go into 15? Once. All right, so 13 goes into 15 once, so we're going to put a 1 above the 5. And then what do we do next for this process? This is a process that you probably learned back in grade school that we don't do very often. From what? Okay, so we have to multiply the 1 by the 13. Good, and then so we'll bring down the 13, multiply 1 times 13, because this answer here, 1 times 13 is 13, goes into 15 once. Subtract, and then there's 2 left over, so then we have to bring down the 6. Next to that, remainder of 2. There's 2 left over after 15 minus 13. Bring down the next number, which is 6. 13 goes into 26 how many times? Twice, okay. And 13 times 2 is 26. And so that's going to subtract with nothing left over. And if we bring down the 9, how many times does 13 go into 9? 0 times. All right. Now, we're not going to keep going with decimals. We're just going to go ahead and stop here, and we're going to have a remainder. And the remainder is 9, right? So we've got ourselves an answer of 120 with a remainder of 9. And so how does that look like if we were to write this as an answer with a remainder? So 9 is the remainder. Go ahead and write that down, remainder. The answer is 120. How do we write our remainder? Anybody know? Because we could say 120 remainder 9, but how many parts make a whole with this division problem? 13. So what is the remainder actually? 9 what? 9/13. So this would be 120 and 9/13. So it is 9 out of the divisor, right? There's 9 left over out of 13 that make a whole. So 120 and 9/13. Now the idea for polynomial long division works exactly the same as this, but it looks a lot different. What I want you to keep in mind is this process for polynomial long division, okay? Because it's going to look a lot different, but the steps that we use in order to get there are going to work the same. So let's go ahead and head over here. And so we're going to jump. We're going to make a big jump. Now we're going to go ahead and take x cubed plus 5x squared plus 6x plus 9, and we're going to divide that by x plus 3. So you can think of this big long polynomial as a number. You can think of x plus 3 as another number, and we're going to write the problem just like we wrote, or just like this one was already written. So you're going to leave a little gap because you need to write some answer parts on the top of it. But we're going to have x plus 3 here. So that is going to be our divisor, and then underneath the division symbol, the dividend, is going to be x cubed plus 5x squared plus 6x plus 9. This sets up exactly like regular long division. So, first thing we're going to do on these problems, we are not, and here's what's a little bit different about polynomial long division versus regular long division. We're looking to figure out how many times 13 went into 15 here. All we're doing right now is using x. Only look at the x right now and figure out how many times x goes into x cubed. Meaning, what do you have to multiply x by in order to make it equal x to the third power? So think about that for a second. how many factors, how many exponents of x are on this one? What's the exponent here? 1. The exponent here is 3. How many exponents are missing? 2. So this gets multiplied by x squared to equal x cubed. And so that's what goes up here, because x squared times x is x cubed. Everybody okay with that so far? So that's what we're starting with. So above the x cubed, I want you to write x squared. Then we're going to do the same thing we do with regular long division. We're going to take our x squared, we're going to multiply it by x, and we're going to write that underneath here, which is x to the third power. Then we also have to multiply x squared by the 3 because there's 2 things in our divisor. So x squared times 3 is 3x squared. So we're going to write plus 3x squared underneath that. Once we have that, we're going to do the same thing we did over here, and we're going to subtract. So I generally put that in parentheses because that negative has to distribute to the x cubed and the 3x squared. So we're going to take x cubed and subtract 3x cubed. What happens if we subtract those? Yeah, they cancel out. This should always be the case. Spirit cat? Yeah, come on in. All right, so let's see. Sophomores, camo / superhero. 1. Okay, juniors, camo / superhero. We got 2, 3, 4. Okay, 4. Seniors, camo / 1. All right. And then DuckTales are absolutely superheroes. If you're a 90s kid, you know that. Okay. All right. So x cubes cancel out. This will always happen with the first terms in this process. Okay. Listen up, guys. Are we writing this down? We write it down? Jaden, Colby, we're writing this down? Okay. So the first terms in this process will always cancel out when you subtract them. And then we're going to take 5x squared, and we're subtracting 3x squared. What's 5x squared minus 3x squared? 2x squared. So we get 2x squared here. And then we bring down the next term, which is 6x. So this process is identical to this process over here. We're just using polynomials as opposed to regular numbers. So the next thing we're going to do is we're going to try to figure out what do we have to multiply x by to make it equal to x squared. Yeah. What multiplies by x to equal to x squared? That would be 2x. So up here, we're going to write plus 2x. That's because 2x times x is 2x squared. All right. We got this, Josh? Pencil, writing it down? Yeah. All right. Next, we're going to multiply. 2x times x is 2x squared. These terms, the first terms with the multiplication and what you had previously, should always match. It matched here with the x cubed. It's going to match here with 2x squared. Then we're going to multiply 2x times 3, which is 6x. And so what's going to end up happening on this one is when we subtract 2x squareds and the 6x's end up canceling out. So now we're left with 0 right there. And that means we then need to bring down the 9. So bring down plus 9. And so our question here is, the question is not how many times does 3 go into 9, because that's not what we're dealing with. We're dealing with x. Can you multiply x by something to make it equal 9? No. That's like asking this question over here. How many times does 13 go into 9? It doesn't. How many times does x go into 9? It doesn't. So our answer for this, down here, when you divide polynomials, you can express the relationship of the quotient and the remainder to the divided and the divisor in 2 ways. So there's 2 possible ways to write our answer. The first one is writing it like we did over here. So our first answer we're going to write is x squared. Actually, equals, okay. So here we go. Let's write the division problem as a fraction and then write our answer. So we're going to have x cubed plus 5x squared plus 6x plus 9 divided by, like this, divided by x plus 3. Thank you. Equals x squared plus 2x with a remainder of what? What's our remainder? 9. Okay, so plus 9 over, what was our original divisor? What do we divide by? X plus 3. So this is our answer. So how many times does x plus 3 go into this polynomial? It goes into it x squared plus 2x times with 9 left over. Division is the same thing we've been doing for the last, or same thing you've been doing for the last however many years with division. How many times does the thing you're dividing by go into the thing that's being divided? And we're expressing it as a polynomial as opposed to a number, but it's the same idea. So the other way that you could write this is multiplying, so the dividend, the thing that you are dividing. So the other way to write the answer would be, let's see, x cubed plus 5x squared plus 6x plus 9. And I'm going to go off to the side here for a second. Would you all agree? Listen up. If you take 20 off to the side here, let's just do a little bit of a side problem. 20 divided by 5 equals 4, right? Everybody cool with that? Everybody knows that? Yeah. Which means that 20 is equal to 5 times 4. So division can be written as multiplication. And so that's what we're going to do for this second one. So this is saying that if we divide it, we get our answer here. But we can also say that the larger thing, the thing that was divided, the dividend, is equal to the answer times the divisor. But we can also add on to it the remainder because that's what we'd have to do. So this is going to be equal to, here we go, the quotient, which is the answer here, which is x squared plus 2x. That was the whole number, right? Our whole number was x squared plus 2x multiplied by the divisor of x plus 3 plus the remainder. Two ways to write our answer then. Because if you multiply those two together, you're going to get everything up until here. X cubed plus 5x squared plus 6x. And you can kind of see that up here because our remainder was 9. So everything from here to here, those two things, the dividend here and the divisor here, divided to equal x squared plus 2x. So those two things multiplied together, x plus 3 times x squared plus 2x, will equal this part of the dividend with an addition of 9 as a remainder. So if you multiply those two together, adding on the remainder of 9, that's the same thing as the original if you multiply those out. So let's try another one. Now, when you are working with these problems, take a look. It is incredibly important. Here's a very important step that I'm going to teach you on this particular problem. The dividend is a cubic polynomial with no first or second degree term. Right here, actually, no, not when the remainder is 0. Sorry, it's not written in here. We'll talk about what happens with the remainder of 0. But if the dividend, listen up, if the dividend, the thing that is being divided, does not have certain values of x, there is no x squared, there is no x. You need to account for the fact that they are not there. So here we go. This particular one, we are dividing by 4x squared minus 6x plus 9. So that is our divisor. That's on the outside of the division symbol. So 4x squared minus 6x plus 9 And our dividend is 8x cubed plus 27, but watch what I'm about to do here. We got 8x cubed. We need to compensate for the place value that has x squared. So we have to include x squared in our dividend. What number would go next to it if it's not in the original polynomial? 0. So plus 0x squared. Same thing with x. There's no x either. So plus 0x plus 27. You must include, hey guys, listen up. You must include values for every exponent on the way down, even if there is no coefficient value in the original problem. They have to be accounted for. So fill in with zeros on the ones that aren't there. All right. Now we're going to do the same thing we did last time. Even though we're dividing by a trinomial this time, the process is the same. We're still looking at the first term here, and we're trying to figure out how many times does that first term go into that first term. So what do you multiply 4x squared by to make it equal 8x cubed? 2x, yeah. 4 times 2 is 8. X squared times x is x cubed. So 2x. So 2x, and then we're going to multiply 2x by all 3 of those. And that's the reason why we need these, because anytime you line up the exponents, it's going to have to line up with the exponents in the dividend. And so if they weren't there, we need to add them in so things line up. So 2x times 4x squared is 8x cubed. Once again, these first terms should always match. Let's see. 2x times negative 6x would be minus 12x squared. And then 2x times 9 would be 18x. And then we're going to subtract, just like we did in the last problem. So set this up here. I'm going to put parentheses around that because all 3 of those things need to be subtracted. 8x cubed minus 8x cubed cancels out. And this is the importance of putting the parentheses with the minus on the outside, because we are not subtracting 12, we are subtracting negative 12. That's a positive 12x squared. Yeah, so we're just going to write 12x squared. And then 0 minus 18 would be minus 18x, and then bring down the 27, plus 27. Because we have a trinomial that we're dividing by, that means that every time over here, we need another trinomial because there are 3 terms that need to match up here and here. Previous problem, we had a binomial that we were dividing by, so everything as we went through it was a binomial. However many terms are over here need to be the amount of terms that you have underneath as you keep working through the process. So now we're going to look at 4x squared and 12x squared. What do you have to multiply 4x squared to equal 12x squared? 3. All right. So 2x plus 3, it's positive 3. And then we distribute that 3 to all 3 of those. So this will be exactly the same, 12x squared. 3 times negative 6x is negative 18x. And 3 times 9 is 27. What do you notice? Everything's canceling out this time, right? 12x squared minus 12x squared is 0. Negative 18x minus negative 18x is 0. 27 minus 27 is 0. So that means that our answer is just 2x plus 3. There is no remainder. Think about what that means for a second. So our answer, you could just write 2x plus 3. That's our answer. Which means if you take 2x plus 3 and you multiply it by 4x squared minus 6x plus 9, you will end up with 8x cubed plus 27. Now over here, it says, when the remainder is 0, like we just saw, you can use the results of the long division to write p of x in factored form. So that means that p of x actually equals this times this. Not only that, this is a perfect square trinomial, and this is 2x plus 3. That actually is a sum of cubes. So we could say this. We could say 8x cubed plus 27 is equal to 2x plus 3 cubed, like we saw with our last lesson. If your first term and your second term in the original thing are perfect cubes, that's a sum of cubes, which just factors to that. So The answer, though, is right here. Now, what this also tells us is, listen up, this is another important idea. Actually, let me talk about regular numbers for a second. With 20, 5 and 4 multiply to equal 20, but if you can multiply two numbers to equal a larger number, that means that the two smaller numbers are factors of the larger one, right? 5 is a factor of 20. 4 is a factor of 20. 13 is not a factor of 1,569 because there's a remainder, right? If you have a decimal or a remainder, the thing you divided by is not a factor of the thing that got divided, right? It's a factor only if it divides evenly. We're all aware of that, right? So like factors of 10 would be 5 and 2. So what that means is with this first one, x plus 3 is not a factor of this polynomial because we have a remainder of 9. However, 4x squared minus 6x plus 9 is a factor of 8x cubed plus 27 because there is no remainder. So this is like a whole number when this gets divided, or sorry, 2x plus 3 is a factor, which means that 4x squared minus 6x plus 9 is also a factor. So if you divide this number by that number, you end up with another whole number. Whole number divided by whole number equals whole number, or integer divided by integer equals integer, means that the two things that you end up with, or the thing you divided by in your answer, are factors because there's no remainder. So even though that looks a lot different, both of these are factors of that because there's no remainder. And that's an idea we're going to be using as we keep going through this. So I want you to try A and B on your own. If there are missing values of x in your dividend, you need to fill in for them. There are no missing exponents for x in this first one, but there are missing exponents for x in this one. Not only that, there's also the divisor that is missing a factor of x, which I don't remember if that matters or not. Yeah, I guess we'll find out. Give it a work. See what goes on with that. Take a few minutes. We'll check back in, work on those. If you have questions in the meantime, feel free to come up and ask. I got a good attendance then, though. So let's see. Hey. What's that?
What's going on today?
We've got some notes. We're working on division with polynomials. Let's see. Get your head up a little bit with that. Yeah. Here we go. So we got X. So we'll double check in just a second. So it looks like this one is saying X minus, but we'll see. Yeah.
Oh,
Okay. I'm not super convinced that the book is always right, so I know. All right, let's have ourselves a look and see what we got here. So with this first one here, we're not missing any exponents or any values of X along the way. So we're going to take, we got X squared minus 4X plus 3. And that's our divisor. Our dividend, the thing that is being divided, is X cubed minus 6X squared plus 11X minus 6. Here we go. All right. So let's see. Josh, how many times does X squared go into X cubed? What's that? 1X, right? So X times. Okay, good. So X goes here. And let's multiply it. X times X squared is X cubed. X times negative 4X is negative 4X squared. And then X times 3 is 3X. We'll line that up. We're going to subtract. The first terms will always cancel. Negative 6 minus negative 4. It's not negative 6 minus 4. So it's not negative 10. What is it? What's negative 6 minus negative 4? Minus 2X squared, yeah. Because we're taking away a negative 4, so we're actually adding 4 to negative 6. So we're not taking away 4 from negative 6 to make it negative 10. We're adding 4 to negative 6 to make it negative 2. Then we're going to take 11 and subtract 3, which is 8. So plus 8X. And then bring down the minus 6. All right. Let's see, Diego. How many times does X squared go into negative 2X squared? What do you have to multiply X squared by to get to negative 2X squared? Negative 2. Good. So after the X up here, we're going to write minus 2. And then if we multiply everything here by negative 2, negative 2 times X squared is negative 2X squared. Negative 2 times negative 4X is positive 8X. And negative 2 times 3 is negative 6. What do you notice? They all cancel. So the answer is x minus 2. Because there's no remainder, which means that x squared minus 4x plus 3 is a factor of x cubed minus 6x squared plus 11x minus 6. So cancel, 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 cancel. There we go. Answer is x minus 2. Are there any questions there? The biggest thing in this process is not going to be the process. It's going to be remembering that subtracting negatives is the same thing as adding. Honestly, that's probably going to be the biggest issue here. Is just remembering that little fact about subtracting a negative, meaning we're adding here. Negative 6 plus 4 is negative 2. Because it's the same process that you learned back in like what, 4th grade for long division? All right, let's try this next one. No, both of these are missing exponents with x, so we're going to fill everything in that's missing with a 0. So we're dividing by 4x squared plus 9, so we're going to get 4x squared plus 0x plus 9 as our divisor. And then our dividend is 16 x to the 4th plus 0x cubed plus 0x squared plus 0x minus 85. A lot of filling in with blanks on this one. All right. David, how many times does 4x squared go into 16x to the 4th?
3 times.
Was that?
3 times.
4 times what equals 16?
4.
4, all right. X squared times what equals x to the 4th? How many more exponents do we need? 2 more, so x squared, 4x squared. All right, then we're going to multiply 4x squared by all 3 of those. 4x squared times 4x squared is 16x to the 4th. Those 2 terms should always be the same. Those lead terms always need to be the same. 4x squared times 0x is 0x cubed. Those are the same as well, so those will cancel. And then 4x squared times 9 is 36x squared. So we're going to subtract. 16x to the 4th, cancel. 0x cubes, cancel. 0 minus 36 is negative 36. So that's going to be negative 36x squared. Bring down the plus 0x, bring down the minus 85. We have to have 3 terms here because we have 3 terms over here. All right, next, how many times does 4x squared go into negative 36x squared? Negative 9 times. Good. So I'm just going to write minus 9 above the x squared. You can put the minus 9 over here as well, which we're going to at the end of the problem. Negative 9 times 4x squared is negative 36x squared. Those are going to cancel. Negative 9 times 0x is 0x. And then negative 9 times 9 is negative 81. All right. There's not going to be a lot of room for a remainder here, but there is a remainder. First 2 terms, those both cancel. Remember, though, we are subtracting here. Negative 85 minus negative 81 is negative 85 plus 81, which equals what? Negative 4. So that is the remainder. So this is the whole number, 4x squared minus 9. With a remainder of, we could write plus, or because it's a negative, I'm just going to write minus 4 over the divisor of 4x squared plus 9. That's our answer there for this one. Anytime you have a remainder, the remainder goes over the original divisor, which is 4x squared plus 9. We don't need the 0x in the answer. That's only to do the division. Okay. Are there any questions on polynomial long division before we move on to another form of dividing? Because there's more than one form of dividing polynomials. They both achieve the same thing. The next one I'm going to show you is actually a relative shortcut if you have certain types of polynomials. Any questions about this before we continue? Yeah, probably. It would be 4x squared plus 9. Yeah, I forgot the 4 down there. There we go. Thank you. Yeah. It absolutely would be 4x squared plus 9. By the way, if your answer was, if you had a plus and then negative 4 over that, that's fine too. There's no difference between that. I just did the minus because that was a negative already. So instead of writing plus a negative, I just wrote it as a minus. Okay. Any other questions before we turn the page? Yeah, that should be a 4 down there in the denominator next to the x squared. 4x squared should match. All right, turn the page. Let's keep going. Now, the next process we are going to be learning, eyes up here, guys, we're not done yet, is called synthetic division. Synthetic division achieves the same purpose as polynomial long division. However, it can be a little bit quicker to use than polynomial long division only if you are dividing by a linear binomial. Meaning, the thing you're dividing by cannot have any exponents with the x, just needs to be a regular x, and then a number after it. Okay? Not even a coefficient with x. Coefficient has to be 1. So if you are dividing, if you got a polynomial, the original polynomial could be anything, but if you're dividing by a binomial that is linear, meaning there's no exponent with the x, and there's no coefficient in front of the x other than 1, which this is here, then you're good to go with synthetic division. It doesn't work with any other method. So synthetic division is a method used to divide a polynomial by a linear expression, right, of the form x minus a, right? So note that the leading coefficient of the divisor is 1, and that a is the 0 of the divisor. What that means is, when you divide, I'll show you what this looks like. To change from long division format to synthetic division format, write only a and the coefficients of the dividend. The value of a here is not -3. The value of a is 3. Because it's not x, so if you look here, x minus a, this is x minus 3. The subtraction is the same from here to here, which means that a is 3. Basically, it says it's the 0 of the divisor, meaning what is the value of x that makes this expression equal to 0? What minus 3 equals 0? What number minus 3 equals 0? 3. That's that number right there, 3. So if this was x plus 3, this would be -3. So it's basically you're taking the opposite of whatever is there that you're putting here. Because what you're doing is you're actually checking, oftentimes when you're using synthetic division, you're checking to see if this is actually a factor of that. And so it's the same idea. If there's a remainder, it's not a factor. If there is no remainder, if the remainder is 0, then it is a factor. So here we go. What you're going to end up doing is, it's a weird form of writing this, first of all. You have your value of a right here, whatever makes this equal to 0 goes here. And then you bring down each coefficient of the dividend. So the lead coefficient is 2. Second coefficient is -7. Third coefficient is 0. Even though it wasn't here, we still have to compensate and put in the 0 for it. And then bring down your constant term of -4. Now, once you do that, so let's go ahead and rewrite this problem. It says bring down the first coefficient, multiply. All right, let's see, 3. And just go ahead and square it off up there. And then next to the 3, we're going to be writing 2, -7, 0, and -4. We're spacing them out a little bit. And then we're going to go ahead and draw a line down here. Make it a little bit further down because we're going to be placing numbers underneath each of these values. So this says to bring down the first coefficient. So 2 gets brought down right here. 2. Multiply the first coefficient. 2. Multiply a by the first coefficient. So a, first coefficient, multiply. What do you get? 6. 6 goes here. Add the result, 6, to the second coefficient, -7. So we're going to be adding these. What is -7 plus 6? -1. Repeat the process. Take this value, multiply by 3. What do you get? -3. 0 plus -3. What does that equal? -3. Repeat the process. -3 times 3. -9. Add those two together. -4 plus -9. -13. So what we end up with here, -13, this right here is your remainder. That's your remainder. And in terms of what's in your answer here, to the left at the bottom, these numbers down here, this is your constant term. Constant term is the regular number that does not have a variable. This is your coefficient that goes with x, and this is your coefficient that goes with x squared. So,
May I have your attention, please? It is now time for juniors in group 1. That's students with the last name starting with letters A through C. A through C, please report to the Career Center for testing.
A through C, head on there. So, chances are you're not going to be finishing our notes today. I am going to hand out the assignment. This is not going to be due tomorrow. This is not due tomorrow. You're probably not going to finish the notes today, but I want to give you a head start on that. All right. Yes. Oh. Yeah, go.
I'm writing it like in the 2x squared minus 1x minus 3. With the remainder, like.
Just what we did on the first page. I'll show you when we get down here. All right. So we divided all the things, or we use synthetic division to make this work, right? And so we've got, so that's going to be 2x squared minus 1x or minus x minus 3 minus 13 over the original divisor of x minus 3. So it's the same type of answer that we had previously. It's just done in a slightly different way. And while this might not seem like a shortcut right now, once you learn this process, it's actually a lot quicker than using long division if you're dividing by a linear binomial that has a coefficient of 1. It's a very limited use case, but when you can use it, it's pretty quick. So we've got the quotient and the remainder, so we're just going to go ahead and write the answer down here, and the answer is going to be 2x squared minus x minus 3 minus 13 over x minus 3 because of the remainder. What's that? Where at? Oh, because right here, negative 13. Yeah, the last number, if there is a last number here other than 0, then that is the remainder. If this number is 0, then there is no remainder, which tells you that the thing you divided by is a factor. Yeah. And again, instead of writing plus and then negative 13 over x minus 3, I'm just writing minus because that's a negative 13. So I'm writing it as subtraction as opposed to adding a negative. But if you wrote plus here and a minus up here, that's fine. Same thing. I like to write as little as possible, and that includes one more line here and one more line there. So you could have written, yeah, you could have had a plus here and a negative up with the 13. It means the same thing. Adding a negative and subtracting are the same. All right. So that is our process for synthetic division. Let's try the next one here. We'll do this one together. So what is the value of a in this problem? What makes this equal 0? 1. Yeah. What minus 1 equals 0? 1. 1 minus 1 equals 0. So we're going to have a 1, and we'll do our little box. And then we're going to write all of our coefficients. We're going to have 3. What's our next coefficient going to be? With the variable x, yes. However, 0. Yep, because there is no x squared, so we need a 0. Then -5. And then 10. And we'll go ahead and draw a line, leaving room in between the line and the numbers above, and leaving enough room underneath the line to write answers. So, first thing we're going to do, bring down the lead coefficient of 3. And then we start our process of multiplication and adding, and then multiply and add, and multiply and add, and see what happens. So 1 times 3 is 3. So multiply the coefficient by the value of a, you get 3. Add those two numbers together, 0 plus 3 is 3. Multiply 1 times 3, you get 3. Add these two numbers together, what do you get? -2. Multiply those two numbers together, you get -2. 10 plus -2 is what? 8. 8 is our remainder, which means that -2 is our constant, the regular number with no variable. 3 goes with x, 3 goes with x squared. So, who can tell me what the answer is written out? -2 plus 8 over x minus 1. You got it. Nice. It's the same answer we would have gotten had we used polynomial long division, like we did on the first page. But we don't have to worry about all that like lining up and subtracting and doing all that. We can just get our coefficients written, the value of a, bring it down, multiply, add, multiply, add, multiply, add. Once you get used to synthetic division, this process is generally quicker than polynomial long division. However, you got to remember you can only use this if you divide by a linear binomial that has a coefficient of 1. All right, questions about synthetic division before we do more synthetic division? Okay. How are we feeling so far? Decent? Okay. This one oftentimes is more challenging than polynomial long division at first because the process for long division is so familiar. So I can see why this would seem a little bit confusing right now. I get that. But in the long run, it is a bit of a shortcut. However, if you have an option, like if all it says is to divide and it doesn't tell you what method to use, you are always welcome to use long division if you'd prefer that. If it tells you to use synthetic division, use synthetic division. Or if there's questions like the ones on the front, we could have used synthetic division for this one. In fact, you know what? Let's do that real quick. Let's do synthetic division now that we've seen it. Let's put that off to the side here. Because we're dividing by a linear binomial with a coefficient of 1. I just want to show you that it's the same process. It takes up less space and it's a little bit quicker. So for this problem here, what's the value that makes this equal 0? -3. All right, so we're going to have -3. And then our coefficient values would be 1, 5, 6, and 9. And then if we bring down the 1, we can start our process. 1 times -3 is -3. 5 plus -3 is 2. 2 times -3 is -6. 6 plus -6 is 0. 0 times -3 is 0. 0 plus 9 is 9. We've got a remainder of 9. There is no constant term. The term with x is 2. The coefficient with x squared is 1. So we end up with an answer of x squared plus 2x plus 9 over x plus 3. Which is exactly what we got the first time, except that took a lot less time. So using the different process, using synthetic division versus long division, we got the same answer, but we got there a lot quicker. And it took up less space. So if you can use synthetic division, I would recommend it, but you don't have to if it doesn't tell you you have to. Every other problem on the first page, we could not have used synthetic division. There's no way we could have, because we divided in part B by a quadratic. That's not linear. It's got 3 terms as well. That doesn't work for synthetic division. Neither did the ones at the bottom. A squared was not a squared, but a down here was also being divided by a quadratic. Doesn't work. This one down here being divided by a quadratic. Doesn't work. So this very first example does work. We get the same answer. It's all good. So let's keep going. Let's head back to the other notes real quick. And all right. So this is actually leads us right into the next question. We don't need to write anything down for this, but let's talk about it. Which method would you use to divide any polynomial by x squared plus 5? Long division or synthetic? Long division. Why? Yeah, there's the squared there. You can't use synthetic division if there's a square. It doesn't work. So even though it's only 2 terms, even though the lead coefficient is 1, because this is a quadratic instead of linear, squared instead of exponent of 1, we can't use synthetic division. It has to be long division. Thanks, guys. All right, let's keep going. All right. This is where we start to use synthetic division a little bit more effectively. And this is where synthetic division usefulness ends up being a little bit better in some cases than using long division. So this says, explore the question. Let P of X equal, so our function is equal to that. Use synthetic division to divide P of X by X plus 5. Okay, let's do that real quick. And then we'll come back and we'll answer this question that's written at the top. But let's go ahead and do the division first and then find out what happens. So what is our value of A? -5. All right. The value of A that makes that binomial equal to 0 is -5 because -5 plus 5 is 0. All right. Coefficient values. What's the first one? Then what? 10, then 29, and then 24. Cool. All right. Set up synthetic division. And I want you to go ahead and solve this one on your own. Work through that. Figure it out. See if there's a remainder or not. No, this is going to be 4. That'll be 5x. That'll be x squared. Yeah. Good, Gabe. It's going to be a little bit easier to go when you're figuring out your exponents is if you start on the right and go from right to left, because it's always going to be remainder, constant, linear, quadratic, and kind of build on your way up instead of going on the way down. So here's our synthetic division. So the bottom row should be 1, 5, 4 with a remainder of 4. So the answer to this in terms of our synthetic division gives us x squared plus 5x plus 4 plus 4 over x plus 5. Now, we're going to use that real quick to say, or to figure out, how is the value of P of A related to the remainder when you actually divide. So if A is equal to -5, which it is, P of A is this function here when we plug in 5 for X. So let's figure this out. Let's type it, not type in, let's go ahead and solve what is P of 5. Or sorry, -5, because A is -5. So A equals -5. Therefore, P of A is -5, P of -5. So we're just going to take our function, our original function, right here, P of X, and we're going to be plugging in -5 for X. Let's see what happens when we do that. So that'll be -5 cubed plus 10 times -5 squared plus 29 times -5, and then plus 24. And I would recommend using a calculator for that, just in terms of making things a little bit quicker for you. What happens? What does P of -5 equal? What does it equal? It equals 4. What was the remainder? 4. Do you think there's something there? I would imagine. So basically what we're saying is, if we were to graph this, there would be a point on this graph at -5, 4. So left 5, up 4 on the graph. That graph goes through that point, which is also equivalent to, 4 is also equivalent to the remainder. So here's what you can do. You can use synthetic division to evaluate a function at a particular value of X. The particular value of X that we just worked on was -5. But think about this. You had to use your calculator to do this, right? Which probably took longer than actually using synthetic division to evaluate. What we just did, those two things are the same thing. Using synthetic division, the remainder, we got an X value here and a Y value here. Plugging in that same value of X into the original function gives us the same Y value, which is the remainder. So if you want to, you can say X, Y, X, Y. Those are the same. Plugging in a value for X into a polynomial is the same thing as using synthetic division with that same value of X. There's no difference. So let's do another example of this, and then we'll call it a day, and we will finish up our notes tomorrow. So we are going to use synthetic division to show that the remainder is actually equal to the Y value when you plug in -2 for X into the original function. So let's go ahead and set up our synthetic division. What does A equal? A equals -2, which right here you can see, you're going to evaluate the function for -2, which this tells you what the value of A is right here. So if we use -2, and then our coefficient values are 1, 8, 12, and 5. And if we go through synthetic division, the answer is 5. And to me, that's a lot quicker than plugging in -2 into that function and solving for Y. So on this particular graph, we have the point -2, 5. If you were to, by the way, you don't need to write the answer as a polynomial because that's not what this question is asking. It's just saying, hey, what's the Y value given that X value? That's what we're doing. If we go with f of -2, that's going to be -2 cubed plus 8 times -2 squared plus 12 times -2 plus 5. I think it's going to take longer to do this than it did using synthetic division. So synthetic division is not only a relative shortcut for division, it's also a relative shortcut for figuring out a value of Y for a given value of X in a function. So let's see, that's -8. That'll be plus 32 minus 24 plus 5. That's -32, that's 32, those cancel, 5 is the answer. So f of -2 equals 5. Ends up being the same thing either way. But this has multiple uses. That's kind of nice. And if you were to graph this, first of all, if you were to graph this, what would it look like? What's the end behavior? Down on the left and on the right? Up. Down on the left, up on the right. Odd exponent, the degree is odd. Lead coefficient is positive, down on the left, up on the right. Opposite end behavior, because the coefficient, lead coefficient is positive, down over here, up over here. This is all going to relate back to graphs and all that kind of stuff. So we got to keep that in mind as well. All right, we got less than 2 minutes. We will finish this tomorrow.